All right, let's look at question 8 of the physical properties worksheet. Straightforward question. During a practical investigation, the boiling points of the first 6 straight chain alkanes were determined. Because it's only alkanes, that means that we don't need to worry about functional group. They all have the same. Okay, which means also they all have the same type of intermolecular forces, and it's alkanes. So all of these have to do with London forces. Okay, and if we look at the graph as we go down, as the number of carbons increases, the boiling point increases. Straightforward. So, next question says, write down the general formula of the alkanes. This is straightforward theory. Nothing difficult about this. You should know in your sleep by now. CnH2n, who knows what I'm about to write? Oh, no, that's also not going to help us. All right, so CnH2n. All right, so let's just take that out. So CnH2n plus 2. Straightforward. Then they say, refer to the table to answer question 8.2 and 8.3 below. 8.2, dependent variable, independent variable, and the conclusion. Straightforward. All right, it doesn't matter if you've never seen this theory before, because you can get it from the table. Remember, you can get it from the table. So, dependent variable is the variable that we change. Okay, so the dependent, not change, is the one we measure. So in this case, the dependent variable is the boiling point. It's what we measured every single time. Okay, the independent variable is what we had control over, and it's what we changed. In this case, it's the chain length. You can describe this as being number of carbons in the chain, molecular mass, molecular size, but it's chain length. Okay? Then they ask us to write a conclusion. Your conclusion, straightforward. As chain length increases, okay, please, whatever you wrote in 8.2 as your independent variable is what you must write here. So if you wrote molecular mass, then you must write molecular mass. I use chain length, so we're going to write chain length. As chain length increases, boiling point increases. Straightforward. Okay, boiling point increases. Nice and easy. Now they say write down the name of an alkane that is a liquid at 25 degrees Celsius. If we go back to our table, all right, these are all boiling points. These are the points where it's going to go from a liquid to a gas. So we've got to look at the ones that are liquids at 25 degrees. These 4 all boil way before 25 degrees. Pentane will still be a liquid, and so will hexane. Both of those will. Now, they just wanted one. They said, write down the name of an alkane that is a liquid at 25 degrees. Both of those are. So for this one, they only want one name. Please don't go and write more than what they wanted. They wanted the name of an alkane. So, what was the first one? Pentane. Nice and simple. Then they say, will the boiling points of the structural isomers of hexane be higher than, lower than, or equal to that of hexane? Refer to molecular structure, intermolecular forces, and energy needed. So there's a lot of things I need to have in this particular answer. What you need to realize is with hexane, remember hexane looks like this. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, I'm not going to put in all the hydrogens because I'm just showing you something quickly. So this is for 8.4. One of the isomers of hexane would be this. 1, 2, 3, 4, 5. And now we have a branch. So in other words, when we get the structural isomers, we're going to have more branches. Okay? Remember, as we have more branches, the surface area decreases. Okay, so surface area gets smaller. What happens as a result of surface area getting smaller? The intermolecular forces get weaker. The intermolecular forces get weaker, boiling point will decrease. Okay, so let's look at the question again so we get this right. Will the boiling points of the isomers be higher, lower, or equal to hexane? Well, they're going to be lower. Okay, so they're going to be lower than. I'm answering the question as asked. Now they want to know why. Well, the isomers have more branches. Okay, have more branches, which means they have a smaller surface area. As a result of the smaller surface area, in this case it's the London forces. The London forces will decrease, become smaller. Therefore, less energy is required to overcome or weaken the London forces. Therefore, boiling point decreases. Straightforward. Really, really straightforward. And you're going to be saying the same thing over and over and over again.